Welcome to Concept Bites, where we break a chapter into small chunks such that they become easy for you to understand. Concept Bites. Easy on your digestion. Alright, so today's topic is magnetic field and magnetic field lines. Class 10th, the chapter is called Magnetic Effect of Electric Current. This chapter, it's a combination of electricity and magnetism. Now, electricity we have already covered quite a lot. If you don't know, go and check it out on the channel right now. And the angle which we are here to cover today is the magnetic field and magnetic field lines, because yahi se kahani chalu hoti hai. If you understand this particular topic, the chapter becomes very easy for you to understand. All right, shall we begin? Okay, let's understand magnetic field and magnetic field lines. Now, before I do that, you press the like button and subscribe to the channel. Yes, come on, do it right now. Let's start from where everything good starts. Everything good starts from exploration, right? So let's talk about our ancient explorers. How did people navigate in ancient times? बहुत पहले time में, how did people navigate? You can say, sir, what about the sun? Not a bad thought. Right now, a sailor is thinking, are we going in the right direction? सही जा रहे हैं क्या हम लोग? It's a valid question. If you are in the open sea, you don't know where you are going. It's a valid question to ask. Now you can say, sir, what about the sun? That's fine. But what about night time? ठीक है, दिन में sun can still give you some help. What about night? Sir, what about pole star? Nice, smart, very good. Did you think pole star? But it is only for people in the northern hemisphere. What about people in the southern hemisphere? You know, right? So, you might have seen in all these movies where we have pirates, we have ships, we have captains. Whenever they need to see direction, what they do? They put their hand in the pocket and take out a small device, है ना? छोटा सा device होता है, and they will open it. Let's go this side, right? It's called a compass, right? So navigating using compass, it made navigation very easy. Now the thing about this compass so special was the needle of the compass points almost towards the North Pole. I'm saying almost towards the North Pole. There is a slight deflection from the North Pole, but you can say it points to the North Pole and almost is being accurate, right? A compass only detects the presence of magnetic field and not the strength. Now, it's a very important point. Compass only tells you the presence of magnetic field. It only tells you direction. It does not tell you how much magnetic field, right? So, but how suddenly we came towards magnetic? Because it is related to magnetism. Right? It is related to magnetism. Now, important thing about compass is, compass detects the presence of magnetic field. But sir, what is magnetic field? We'll discuss. But right now, just listen to me very carefully. A compass can tell you the presence of magnetic field. It cannot tell you how much magnetic field is there at that point, right? So, important thing about compass is, it points towards the North Pole and it tells you the direction and not the strength of the magnetic field. Now, we can say, is it enough for us to understand? Let's see. एक question कर लेते हैं फटाफट. The north end of the magnet of a compass installed in a ship align itself to Earth's dash pole. Come on, we just did this question. The north end of the magnet of a compass installed in a ship align itself to Earth's dash pole. Sir, you just told me. You're right. Come on. If you know the answer, tell me right now. A is magnetic north, geographical east, geographical south. North and south I understand, but suddenly what is this magnetic north and geographical north? You know, we are talking about North Pole of the Earth, right? It's more towards geography. So you are right if you are thinking the North Pole of the magnetic compass points to the North Pole of the Earth. That's correct, but it's the geographical North Pole, and that, my friend, is the correct answer. Option B. This is called as the North Pole, the top wala, hai na? Bottom wala is called South Pole. So you're right. Compass points towards the North Pole. The north side of the compass points towards North Pole. But why are we giving these names as magnetic north, magnetic south, geographical north? क्यों बोल रहे हैं ऐसा अलग-अलग? Is it something different? Yes. But before that, let's think about it. Why is this magnetic compass का needle is pointing towards north? Is this needle magical? क्या कुछ खास है इसमें that it always aligns itself in north-south direction? कुछ तो होगा यार, है ना? Because this needle is not a needle, it's a magnet. The needle of a compass is nothing but a freely suspended piece of magnet. Tiny, but it is a magnet. And the north pole of this magnet is pointing to the north pole of the earth, right? Now, इसके बाद आता है flashback. Flashback of class 6th. Remember, fun with magnets एक chapter हुआ करता था, if you remember, right? Here, in this chapter, we learned about magnets. We experienced about magnets. It's there on your BYJU'S 6, 7, 8 channel. Now, हमने क्या पढ़ा था? We learned about magnets and magnetic materials. What is a magnet? An object which attracts other magnetic materials like iron, cobalt, nickel, or other magnets. It is a magnet. Simply, है ना? Right? It's a non-contact force. What different types of magnet do we have? Sir, we have learned about bar magnets, where two extremes are the two poles. Ring magnet, है ना? Which looks like a ring. We have a cylindrical magnet, looks like a cylinder, and we have a horseshoe magnet, है ना? घोड़े की नाल जैसा दिखता है. That's why we call it the horseshoe magnet. Now, if there is a magnet, means it will have poles, right? The poles of a magnet. What is a pole? Pole is the points where the magnetic force is the highest for a magnet, right? The point of extreme magnetic field, so magnetic force you can say. Every magnet will have two poles. I'm telling you, every magnet. Now, if it is bar magnet, two extremes are the poles, north pole and south pole, right? This is your north pole, this is your south pole. In ring magnet, one face becomes the north pole and another face becomes the south pole, है ना? Simple सी बात है. Cylindrical magnet, two extremes are the poles. Horseshoe magnet में, this is your north pole and this is your south pole. This is very easy to understand, and we have done this in class 6. It was a quick flashback for all of you. But why are we doing this? We are doing this because we have to reach a conclusion. एक और चीज बची है flashback में. How the poles behave when you bring them together. Like poles don't like each other. When like poles see each other, what do they tell? पास नहीं आना. Go away. दूर दूर जाओ मेरे से, right? So like poles don't like each other. Like poles they repel. Unlike poles they like each other. Unlike poles they attract. When an unlike poles see to each other, they बोलते हैं अरे मेरा दोस्त, अरे come यार, come close to me यार, sit next to me. This is unlike poles, right? So unlike poles attract, like poles repel. South and north, if you bring them together, they will attract. North and south attract. North and north repel. South and south repel. So like poles repel, unlike poles attract. Again, let's come back from the question we started with. We started from this needle is a magnet, but this needle is always getting attracted towards the north and south pole of the earth. A magnet can be attracted by either magnetic materials or a magnet. But magnetic material, to we have so many around us. If there is no other magnetic material around this magnet needle, है ना? But still it goes towards north and south. कुछ तो होगा, है ना? There must be something. You know, there is. Earth is a giant magnet, but a weak magnet. Yes. Earth is a huge magnet. Yes, but a weak magnet. Now, think about it. The north pole of your compass needle is pointing to the north pole of the earth. North pole is getting attracted towards the north pole of the earth, but that is not possible. North, if that is actually the north pole, as we know north pole, that should repel this north pole of the magnet, है ना? If north pole of the compass needle is pointing towards north pole of the earth, this north needs a south to be attracted. Means that north is not north. That north is magnetic south. So north pole of the earth is actually the magnetic south pole of the earth. Understood? It's easy, no? North pole of a compass points towards north pole of the earth. But it is between you and me. We know why. Because that north pole, the geographical north pole, is actually the magnetic south pole, right? And इसमें एक slight deflection होता है. Geographical north is here. एकदम सीधा, right? But there is a slight angle. There is a slight angle where this magnetic axis lies. This is your magnetic south, right? So geographical north is your magnetic south with a slight angle. Your geographical south is your magnetic north again, right? So you understand, north pole is magnetic south, south pole is magnetic north. Easy, and that is the reason magnetic compass needle behaves the way it does. Alright, now why does it happen, you can ask me. I won't go too deep into this, but I'll just let you know. Inside the earth, there is motion of metallic fluid. Molten metal is moving here and there, right? Correct? And it has charges. There are charged particles, है ना? Ions are there. When these charged particles are moving in this current, they form a magnetic loops, right? These magnetic loops kind of makes the earth magnetic, and all the heavenly bodies, they're sort of magnetic. Think about the sun. Sun has huge magnetic fields, right? So that's why this is something that results in electric current loops, and hence the magnetic field, as we know. So earth behaves like a huge magnet, but a weak magnet, right? Okay. Now, there is the concept of magnetoreception. it is a way of sensing this Earth's magnetic field, right? So compass was kind of doing magnetoreception. It's not just the compass. There are organisms, there are living bodies who can sense the magnetic field of the Earth. Like, you might have heard this, no? Kabutar ja, ja, ja. People used to use pigeons for sending letters, right? Telegrams, small, small. Olden days. In movies you might have seen. Q. I mean, the pigeons, they were very good with address. They were like postmen. No. They were good in finding the direction using the magnetic field of the Earth. They had a property of magnetoreception. They can sense the magnetic field of the Earth, and that will tell them north idhar hai, south idhar hai. Okay, okay, okay. Right? This is the magnetoreception. And many animals can do it, right? Sea turtles can do it, right? Alright, so this is magnetoreception, but why? Main question is, how can someone send or sense this field? How does one magnet know that there is another magnet over there? Think about it, no? But if you have one magnet and you bring another magnet ka unlike pole, okay? This magnet does not know that there is another magnet over here, but still when you bring them close enough, what happens? Katak. They get attracted. Why? How does this magnet know that there is an unlike pole sitting over here? कुछ तो होगा ना. There must be some way in which they talked to each other. अच्छा, unlike हो. How did they talk? Right? There is this region around a magnet where you can sense the magnetic properties. This is called as the region of magnetic influence. Look at this magnet. Around it, there is this region where you can sense the magnetic field, or I would say where you can experience the magnetic force because of this magnet. This region is important because this region is telling you that yes, there is some magnet over there, right? So, how to find, or how to, I would say, know how is this region? Kya hai ye region? Can we visualize it? Because it is invisible. Is there a way to visualize this? Yes, there is a simple experiment you have been doing since class 6th. बचपन से करते आ रहे हो तुम लोग. This is called as the magnet and iron filing experiment. You take any kind of magnet, most good pattern you will get from a bar magnet. It's easy to get also. Go to a stationery shop, take a bar magnet and put it on a piece of A4 paper, है ना? उसके ऊपर just sprinkle iron filings. Sir, what are iron filings? It's just, you can say, powdered iron, right? When you sprinkle iron filings over this, you will observe the pattern and check out the alignment of the iron filings around the magnet. What will happen? You will see there's a special pattern in which these iron filings are arranging themselves, right? This pattern is what we call as the region of influence, right? So the region of magnetic influence around a magnet is called as magnetic field. This experiment which we just did is a way to visualize this pattern, right? So these are called as magnetic field lines. They are imaginary lines which tell you about the magnetic field around a magnet, right? And iron filings is one way in which you can figure out what pattern this magnetic field is there, right? Okay, fine. Now think about it. Iron filings can help you to figure out the pattern of the magnetic field, correct? Yes, sir. They form sort of lines, right? They form a sort of lines. We call these magnetic field lines. So what are magnetic field? Magnetic field is a region of influence around a magnet where you can sense the properties of magnetism. Or magnetic field is a region around a magnet where you can experience magnetic force. Alright. What are magnetic field lines? Magnetic field lines are imaginary lines which tell you what is the pattern of magnetic field around a magnet. Alright. How you can sense them? Iron filings, that is also true. But there is a limitation to it. Let me give you a statement and tell me true or false. Iron filings will tell you the direction of magnetic field lines. True or false? 3, 2, 1. That's false. Iron filings will give you a pattern, but they will not tell you where the field line. What is the direction? Think about it. Will this pattern tell you, is it going from here to here or here to here? I don't know. It's just a pattern, right? So this is telling you, giving you the visualization of the magnetic field, but not the direction. For direction, you have to go even more precise. You have to use the compass again. And think about it. Compass is a brilliant thing here. Compass is telling you, if you put a compass over here, a compass always aligns itself in the direction of magnetic field at that particular point. North side of compass will get repelled from the north pole of the magnet. Yes, you're right. So if I keep a compass over here, this is north, means north pole of the compass will show this direction, right? This direction, correct? Correct, fine. Now, if I put this compass over here, it tells you the direction of magnetic field at that point, and that point the magnetic field is a tangent. So this compass is telling you the field at that particular point. It is in this direction. Similarly, this compass is showing you the field in this direction. That's also true. And people, if you have watched my NCERT explanation video of this chapter, go and understand this, because I have explained this properly, है ना? एक बार दोबारा देखना. I've explained this very properly. बहुत time लगाया था हमने इस पे, right? Go ahead and watch that session, at least the small part, right? This compass is telling the field at that particular point. It's a tangent. Similarly, if you think about over here, it is a tangent, means in this direction. And this is a very common question asked in your board examinations. They will give you a compass and ask you direction of magnetic field. You should know it gives you the direction of magnetic field at a tangent or at that particular point, and it's usually is a tangent, right? है ना? ठीक है? That's true. Now, this is an experiment you do in your school also. Trace the magnetic field lines around a magnet. What do? You take a compass, यहाँ रखा, यहाँ रखा, यहाँ रखा, यहाँ रखा, यहाँ रखा, यहाँ रखा, and this will give you different points, right? Simple. So that's how you have to form the magnetic field lines. To trace magnetic field lines, I will use iron filings or compass. Better is compass, right? You will use compass because it will give you direction also. Fine. Properties. This is where the most important questions come from this chapter. And it's a very common board question also. Give two properties of magnetic field or magnetic field lines. First, they go from north to south outside the magnet. Think about it. हम क्यों बोलते हैं that it goes from north to south outside the magnet? Why can't we just say magnetic field lines, they start at north and they end at south? Because they don't. Outside the magnet, they go from north to south. But these magnetic field lines, they form continuous closed loops. यानी कि outside, if they are going like this, inside it will be going here. So these magnetic field lines, they form closed loops. In the case of a bar magnet, outside the magnet it is going from north to south. Inside the magnet it is going from south to north because it's a closed loop. ऐसा नहीं है कि वो start हो रहा है north पे खत्म हो जा रहा है south पे. ना, it's a closed loop. ठीक है? They are stronger at poles. Poles are the point of extreme magnetic field or magnetic force. सबसे ज़्यादा होती है ना? That is poles. So that's why it is stronger at the poles. We know that. And field lines, they do not intersect. Why? I told you, a compass will give you direction of magnetic field at that point. Think about it. If magnetic field lines intersecting, है ना? If two magnetic field lines are kind of intersecting like this, one here and one here. If I put compass at this point, if I put compass over here, will it point here or here or both? That's not possible, no. A compass cannot point in two directions at one particular instant. No, that is not possible. So that's why they don't intersect. You can say, right? Now, stronger at poles means they are closer to each other. Wherever you see magnetic field lines very, very close to each other, you can say it is the high or strong magnetic field, right? Uniform and non-uniform magnetic field. Where lines are parallel to each other, we say it is uniform magnetic field, means you can say it is constant. In this region, magnetic fields are constant. At every point, you will find equal magnetic force. Field strength at any point is same. That is why uniform. Non-uniform, field lines are not parallel, like a bar magnet. You can see at few points, the field lines are close to each other. कहीं पे they are far from each other, right? So field strength is more where the field lines are closer. जहाँ पे field lines close होंगी, you will say this is where the magnetic field strength is more. It's again a very common question in boards. How it happens? Point A, point B, point C. Where is magnetic field the strongest? Commonly it can be asked, right? Let's do a few questions just to check हमको आ गया कि नहीं आया. फटाफट करेंगे, ठीक है? The region of influence around a magnet can be represented by magnetic field lines. The magnetic field around a bar magnet always forms what? We just did this. Come on, answer me. क्या होता है? Does it form open loops? No sir, that's wrong. Helical lines, I'll tell you. Straight lines तो गलत बात है. Closed loops, yes. Option D is the right answer. But what are helical lines? Helical मतलब like a spring. Helical lines are like this. It looks like a spring, है ना? ठीक है? So helical lines, although You understood what is helical, but it is not correct, no? It is closed loops. So correct answer is closed loops. Magnetic field around a bar magnet always forms closed loops. Okay. Choose the correct option regarding the magnetic field around a bar magnet. You have 4 options. ध्यान से पढ़ो, just read them carefully and then think. Think about it. Which is the correct option? Option A, directed from north to south inside the magnet. If you read the options carefully, no, you will realize more than one option can also be correct in this. How? Let's see. Directed from north to south inside the magnet. नहीं यार. Inside the magnet, so it is not north to south. North to south is outside the magnet. So A is wrong. Directed from south to north inside the magnet. Yes, in the case of this bar magnet, inside the magnet, it will go south to north and outside is north to south. That's true. Very good. So second is true. It is dense at far away from the magnet. You're right. If you go away from the magnetic force is less, magnetic field is less. So how do you know? Two magnets don't always have enough force to attract the other one. They are attracting, but abhi utna strong nahi hai force. They only are able to attract each other properly when you bring them close enough. ऐसे, tuck. Here, it was attracting, but still not able to overcome the friction. है ना? ठीक है? So that's why. When you are far away from the magnet, the magnetic field lines are far apart. They are distant from each other, right? Not dense. Because dense का मतलब होता है strong. So this is wrong. Dense at poles of the magnet, that's true. Pole is the point of highest magnetic field strength, right? So this is where the magnetic field lines are dense. That's true. So option B and option D are the right answer. Easy, clear? Okay. If the magnet shown in the figure is brought near the compass, which direction will the red tip of this needle point towards? That's a nice question. Where will the red tip of this compass point towards? And you have 4 directions in the option. Think about it. Come on. If you know the answer, pause the video and tell me in the comment section. ध्यान से बताओ. देखो. Red in a compass is the north. This I told you already. है ना? Compass के अंदर the red वाला portion, the red वाला segment is the north pole of this needle, the compass needle. ठीक है? North will be attracted towards south of another magnet, which means the north of this compass needle will be attracted like this. Yes, you're right. It will stay like this. Why? Because there is south pole over here. Unlike poles attract, that's true. Now the question is, what is this direction? This direction is what direction? And that is where this will be helpful. Ye north, east. This direction is right now exactly in between north and east. North and east. Northeast. Answer is northeast. And that's why northeast is the right answer. I hope this question was easy for you. है ना? Let's just summarize everything very quickly. ध्यान से. Poles of a magnet. Every magnet has 2 poles. Bar magnet ka we have 2 poles. Cylindrical magnet, horseshoe magnet, ring magnet. There are 2 poles in a magnet, north pole and south pole. And same is with Earth, because Earth is a giant but a weak magnet. The geographical north pole is the magnetic south pole. The geographical south pole is the magnetic north pole, right? Fine. Properties for magnetic field lines. North to south outside the magnet. They are continuous closed loops. They are stronger at the poles, and that's why magnetic field lines are close to each other at the poles. The field lines, they do not intersect. We understand why, right? This is enough. If you understand everything in today's session, hit the like button, because this is very important for your chapter of magnetic effect of electric current, right? So everybody, subscribe to the channel, like this video, and share it with your friends. We'll meet again with another bang on session for you, right? See you. Take care. Bye-bye.